Hi everyone. JNTU Anantapur second year Tribly second semester. What is the syllabus? And regarding that second year second sem syllabus, according to that, the subject names are numerical methods and probability theory, electric circuit analysis, engineering electromagnetics, power electronics, analog electric circuits, Python programming, and two labs and one subject. Now we go for the very tough subject, that is engineering electromagnetics. If you understand the subject, it is very easy to score the maximum marks. If you not understand the subject, it is very difficult to pass also. Engineering electromagnetics, that is third one. Coming to the syllabus of engineering electromagnetics, previously the subject name is engineering electromagnetics, subject name is electromagnetic fields, EMF we call simply. Now the subject name was engineering electromagnetics. In this, electric fields and magnetic fields will be studied. What are the main objectives of electromagnetic subject is to understand the basic principles of electrostatics, magnetostatics, and time varying, time invariant fields, to understand the principle of conductors, dielectrics, and magnetic potential. That is the syllabus course objectives of engineering electromagnetics. To understand electromagnetics, engineering electromagnetics, electrostatics is the unit 1. Before studying the electrostatics, we have to know what are the vectors, what are the various operations in vectors like addition, subtraction, multiplication, and what are the various coordinate systems required to represent any point charge. Different coordinate systems like spherical coordinate system, Cartesian coordinate system, and cylindrical coordinate system, 3 coordinate systems, and vectors. And vectors algebra is most important for entire chapters from first unit to fifth unit. Hence we go for first, before starting electrostatics, we go for vectors. Why we have to know vector? Because here we know vectors are both have magnitude and direction. Suppose a force is there. The force is one particular direction and it has some Newton force, some quantity of force, that is newtons. That is magnitude and direction both have. In electrostatics, electric field intensity is a vector, and different vectors we have to understand in electrostatics. Hence we go for electrostatics. Before starting the chapter, we have to know what is vector, what is scalar, what are the operations. Let us start that. The vector analysis is very important for engineering electromagnetics. What is electromagnetics? First we have to know. What is electromagnetics? Electromagnetics is the branch of physics or electrical engineering in which we are studying the electric field and magnetic field. Electric field and magnetic field and closely related. The electric and magnetic fields are closely related to each other. If there is a magnetic field, there is an electric field. If there is electric field, there may be a magnetic field also. Let us see what are the scalar, what is a vector, what is electromagnetic fields. The study of electric field and magnetic field is known as electromagnetics. Hence vectors are closely related to electromagnetics. In engineering electromagnetics, 3-dimensional representation can be made easy by the use of vector analysis. 3-dimensional representation plays important role. Therefore, 3-dimensional representation can be made easy by the use of vector analysis. Hence, 3-dimensional can be made easy by the use of vector analysis. And a vector analysis is important before starting the electrostatics. Electrostatics కానీ magnetostatics కానీ entire chapters, electromagnetics లో entire chapters అర్థం కావాలంటే ఖచ్చితంగా వెక్టార్ అనాలిసిస్ వీ హ్యావ్ టు నో. Without vector analysis you can't understand. Hence, first of all we have to go for vector analysis. In engineering electromagnetics there may be so many quantities, that is electric field, magnetic field, like that. They can be divided into two. One is scalar, another one is vector. The various quantities which are involved in engineering electromagnetics, they can be classified as one is scalar, another one is vector. Scalar and vector. Second one is vector. These are classified. What is scalar? First of all, what is meant by scalar? Scalar is a quantity whose value may be represented by a single real number which may be positive or negative. The direction is not at all required for the scalar. Scalar is a quantity which value has only magnitude but not direction. Direction is not required. Only magnitude will be considered for scalar. Whereas scalar is a quantity which is wholly characterized by its magnitude only. Only magnitude will be considered. The various examples of scalars quantities examples are temperature, only magnitude will be considered. The temperature direction will not be considered. Temperature, mass, volume. Mass is a scalar. Mass, volume is a scalar. Density, speed, electric charge is q, it is a scalar. These are the scalar quantities. Coming to vector. Vector is a quantity that is characterized by both magnitude and direction. Both magnitude and direction it will be considered. Hence, magnitude and direction both will have vector. The various examples of vector quantities are, what are the examples for vector quantities? The vector quantities are, what is a vector? Vector is a quantity which is having both magnitude and direction. Both it has magnitude and direction. The various examples of vector quantities are force. Force is in a particular direction and some magnitude. Velocity v, it has also some particular direction and magnitude. Where simply electric field intensity. What is electric field intensity? That will comes in first unit, electrostatics. Electric field intensity, magnetic field intensity, h also is a vector, and acceleration. These are the various quantities which can be have both magnitude and direction. Hence, vector analysis is important because electric field and magnetic field both are vectors. Electric field is nothing but E bar, electric field intensity, and H bar is magnetic field intensity. These are so vectors, hence vector analysis is important. Next one is scalar field. The next one is scalar field. What is scalar field? You know scalar. What is scalar field? What is scalar field? The distribution of scalar quantity. The distribution of scalar quantity in a definite position in a space is called scalar field. For example, manaku temperature చూద్దాం. Temperature, if you consider temperature, the temperature is a scalar. For example, the temperature of atmosphere, it has definite value in the atmosphere but no need of direction to specify it. Hence, it is a scalar field. Temperature is a scalar. That means the distribution of scalar quantity ఒక in a definite position, ఏ పొజిషన్లో అయినా కూడా in a space is called scalar field. Suppose the temperature, one object is there, ఒక ఆబ్జెక్ట్ ఉంది. ఈ టెంపరేచర్ ప్రొజెక్ట్ చేస్తుంది కదా, అన్ని డైరెక్షన్లో వెళ్తూ ఉంటుంది, ఒక డైరెక్షన్ అంటూ ఉండదు. ఇట్ ఈజ్ ఏ టెంపరేచర్ ఈజ్ ఏ స్కేలార్. అంటే ఒక స్కేలార్ చుట్టూ ఉండే ఫీల్డ్ని స్కేలార్ ఫీల్డ్ అంటారు. ద డిస్ట్రిబ్యూషన్ ఆఫ్ స్కేలార్ క్వాంటిటీ with a definite position is called scalar field. For example, temperature magnitude ఉంటుంది కానీ డైరెక్షన్ ఏ డైరెక్షన్లో అయినా ఉంటుంది. నో నీడ్ ఆఫ్ డైరెక్షన్ టు స్పెసిఫై ఇట్. It is a scalar field. The height of surface of the earth above the sea level is a scalar field. The height of surface of the earth above the sea level also scalar field. Other examples of scalar fields are sound intensity in auditorium. ఆడిటోరియంలో సౌండ్ ఏ డైరెక్షన్లో వెళ్తుందంటే మనం చెప్పలేం. సౌండ్ ఇంటెన్సిటీ, లైట్ ఇంటెన్సిటీ ఆల్సో ఇన్ ఏ రూమ్, అట్మాస్ఫిరిక్ ప్రెజర్స్, ఇవన్నీ స్కేలార్ ఫీల్డ్స్ అనమాట. అంటే స్కేలార్ చుట్టూ ఉండే ఫీల్డ్ స్కేలార్ ఫీల్డ్ అంటారు. అలాగే వెక్టార్ ఫీల్డ్ అనేది చూద్దాం ఇప్పుడు. నౌ వి గో ఫర్ వెక్టార్ ఫీల్డ్. వెక్టార్ ఫీల్డ్ వెక్టర్. ఈ వెక్టార్ ఫీల్డ్ అంటే వెక్టార్ చుట్టూ ఉండే ఫీల్డ్ వెక్టార్ ఫీల్డ్. ఇఫ్ ద క్వాంటిటీ ఈస్ ఏ వెక్టర్, the space surrounding of any vector is known as vector field. If the quantity is suppose the A is a vector, the quantity which is specified in a region to define a field is a vector. The quantity of field, it is a vector, then corresponding field is called vector field. For examples of vector fields are gravitational force. The gravitational force on a mass in a space is a vector field. This force has a value at various points in a space and always has specific direction. The gravitational force have one specific direction that will be. Hence it is a vector field. For example, gravitational force. Force is a vector, we know. Gravitational force is a vector field. The other examples of vector fields are velocity of a particle in a moving fluid. Suppose the fluid is moving, velocity of any particle is a vector field. Wind velocity also vector field. And voltage gradient in a cable, that is also vector field. Displacement of a flying bird in a space. The magnetic field existing from north to south field, etc., all comes under vector fields. Okay, what is vector field? If a quantity which is specified in a region to define as a vector, then corresponding field is called as a vector field. For example, that one. Now we go for another representation of vector. Representation of a vector. How to represent a vector? Now we go for representation of vector. Representation of vector. Assume that A. In 2 dimensions, vector can be represented by a straight line with a arrow in a plane. Suppose starting point of vector is, this is the starting point. Assume that it is a starting point O. And terminating point of vector is A. Assume that the vector can be represented by a straight line with an arrow. Arrow is the important in a plane. This is shown in this diagram. The length of the segment is the magnitude of vector. ఈ length ఎంత ఉంటుంది vector అనేది depends on magnitude of vector, while the arrow indicates direction. ఈ arrow ఏ విధంగా అంటే O to A అని అర్థం. అదే ఈ arrow ఈ డైరెక్షన్ ఉంటే A to O అని అర్థం. Suppose the direction is in this direction. In both directions it is not possible for vector, only one direction. Suppose A to O, it is also one direction. The magnitude అంటే ఈ లెంత్ ఆఫ్ ద సెగ్మెంట్ ఎంత ఉందో దాన్ని మ్యాగ్నిట్యూడ్ అంటాం. అలాగే డైరెక్షన్, ఇట్ ఈస్ వెరీ ఇంపార్టెంట్. The length of the segment is the magnitude of a vector, while arrow indicates the direction of vector in a given system. The vector in this diagram symbolically denoted as OA is the vector. OA is the vector, and we can draw a line. The point O is the starting point, A is the terminating point. Its length is called magnitude, which is assume that the length is magnitude r. The magnitude is represented by r. The length of the vector is indicates magnitude. OA, magnitude of OA equal to r. The magnitude of OA equal to r, we can say. Okay, the magnitude of OA is called r. Okay, vector length of the line indicates that magnitude అనమాట. అంటే ఈ magnitude r అని చెప్పాం. r అంటే magnitude. Or we can assume that any word also. Or assume that it is a vector. OA is the length of the vector. Length of the vector is nothing but magnitude. Means we can write mod of a OA equal to r అని రాయొచ్చు. అంటే vector can be represented by OA or simply r, magnitude of vector is. Next we go for unit vector. What is the importance of unit vector? The importance on how to define unit vector. How to define unit vector. Next, eighth one, unit vector. Unit vector, as the name says, unit vector. What is this? Unit means only one, whose magnitude is 1. A unit vector has a function to indicate the direction of any vector. Suppose OA, already we show that O and A is the vector, has direction is given by indicate the unit vector small OA. It is a unit vector. The magnitude of unit vector is 1. That's why it is called unit vector. Unit vector has function to indicate the direction. Its magnitude is always unity. What is the magnitude of A, OA? A is the unit vector and OA along the OA direction. That is equal to 1. ఇక్కడ యూనిట్ వెక్టర్ స్మాల్ a OA and represent this. Magnitude of unit vector is always 1. Okay, now what is the purpose of unit vector? To indicate the direction of any vector. The magnitude of unit vector is 1. We have to remember this. How to get this magnitude? The unit vector magnitude is given by how to get unit vector AOA or A, simply A is the unit vector. This will be obtained by magnitude of OA vector divided by its magnitude, that gives 1. Vector divided by its magnitude. How to calculate? ఎలా యూనిట్ వెక్టర్ కనుక్కుంటామంటే ఒక వెక్టర్ OA డివైడెడ్ బై దాని యొక్క మ్యాగ్నిట్యూడ్ డివైడెడ్ బై చేస్తే మనకు యూనిట్ వెక్టర్ వస్తుంది. యూనిట్ వెక్టర్ మ్యాగ్నిట్యూడ్ ఎంత ఉంటుంది మీరు చెక్ చేసుకోవచ్చు. మనం నెక్స్ట్ రాబోయే క్లాస్లో కూడా యూనిట్ వెక్టర్ మ్యాగ్నిట్యూడ్ ఈస్ ఆల్వేస్ 1. ఓకే, వెక్టర్ వీ హ్యావ్ టు రిమెంబర్ వెక్టర్ డివైడెడ్ బై ఇట్స్ మ్యాగ్నిట్యూడ్, బికాజ్ కూలుమ్స్ లా అనేది ఒకటి వస్తుంది యూనిట్ 1లో. ఇన్ యూనిట్ 1 కూలుమ్స్ లా విల్ కమ్. That in that vector, unit vector is very important.